Now say this is LLC prototype, IRC prototype, yeah? A. General view, something like that.
Yes.
B. Passband. Only this part, but with a very large scale to see the ripple in accordance with your specification. You see, because we need it and that should be exactly what we need. You know. Yeah. So, general view. Yeah. This here, passband. Okay. So, no, but I think that's correct. And the comparison of these two responses, yeah? They should be equal.
Yes.
Okay?
Okay.
Yeah. Just now, is it possible to demonstrate the passband? Do it. And in accordance with your specification, cutoff frequency, which is?
Oops.
How much? Well, it depends on you. Of course, you should understand clear what you have, which is your results, compare it with the specification, and it should be correct. You know, yeah. So, this is the first. The second switch capacitor filter. Low pass, yeah. Low pass. Time domain. Time domain simulation, yeah? What we need? Input signal is frequency, of course. This is the input signal. This is in, yeah? Out, of course.
Okay, yeah.
No, you know, we have considered this 1 week ago. You remember about it. I demonstrated you an example. And just now, did you do this or not?
How to use correct time domain in cut microcut? How to?
The open analysis. No.
No.
Stop. No, it's not correct. Transient. Open analysis. Transient, look. This is, yeah, the first one, transient. Yes, this is the time domain analysis, transient. Okay?
Stepping.
Why stepping? I think no, it is not necessary. And first of all, you should understand how to simulate in time domain your prototype.
Yeah.
To understand how it works, because it will be possible to do this operation with the prototype. And after all, you will do it with switch capacitor. But for your training, because you do not have an experience on this topic, for your training, do it with this continuous time filter,
Yes.
with analog, and after all you will do this one,
Okay.
but in the time domain, because just now you have simulated in frequency. It is not the same. Okay?
Yes.
No, so let's go to another audience. Yeah. We'll go to your colleagues. Yeah. Yeah, sure, let's go. No. Ah, your kids.
Yeah.
4 minutes more. Ah, yes. Oh, yeah. Nevertheless, okay, we will see. So, who will be the first?
For the question.
Who will be the first? Just now we have the practicum. It means that I would like to see your results.
Yeah.
Who will demonstrate it first? Yes.
I can.
Yes, yes, please.
Just choose.
But anyway, you see, you see. So we will start from the prototype. So
Yes.
it means that first of all, yeah, demonstrate please the results concerning the. This is the passive. This is the passive. Right?
Okay.
Mhm.
Okay. So I took first.
Yes,
my
yeah, of course, of
reverse
course. No, no,
swap.
just now I will see it after all. Just now only the results, you see, to understand where are you now.
Yeah. So I have my
Uh-huh. Yes, okay. This is the prototype. Three types. Bathroor, Chebyshev, Kawa.
cover.
Yeah. Bathroor, Chebyshev, Kawa.
Good
Mhm.
attention. Yeah. It's my.
It is in accordance with specification, yeah?
Yeah.
That's
Because
correct.
I put my cursor here and I have.
Yeah, I see.
Like it was at least minus 66,
Yes.
so all the three are okay.
Mhm.
And
This is a plus band.
no, it's when I zoom here
Ah.
for the rifle,
Mhm. Okay.
and it's okay too. It's under 0.01,
Mhm.
and I have my phase response, but it's
Yeah.
not. Yeah. After I did a little
Mhm.
table
Mhm.
to sum up, and after so I have approximated with all my transfer function.
Mhm.
I have done so my
This is the active filter.
active filter, yeah,
Mhm.
with injectorless
Mhm.
circuit.
Yes, yes.
So I have all my values, and here so I have my my
Uh-huh.
response. Just I have a problem for that.
Yes.
In terms of like beginning here, I can show you. It was check picture, for example, DB this one, and DB out here, and here it's not so good. We'll go into check, and from one, for example, yeah. Just take like limits. In general, it runs. I know it's okay. It's just because of I think the last thing with my capacitor. I will just copy and paste another one because it doesn't work for the
You can
moment.
disable it.
Really?
Just mark everything.
Here?
Yeah, and then place the red cross.
Here?
Yeah.
Ah, cool. Thanks. I didn't know. So here, here. No. So I have all.
You see, normally, yeah, I see.
It's
The question is that the first one corresponds, I think, well, this one corresponds to the specific prototype,
Yeah.
and here we should have -6.
Yes. It
Open,
is.
is it correct?
Yeah.
Yes, open, please, to understand that. Is it correctly? Oh, yeah,
Yeah.
That's good.
-6.
exactly. And for active filter, we should have 0.
0. It's okay.
It's okay, yes.
So
That's good.
here we see, but yeah.
And what is about the cutoff frequency here? I mean, do we have it in
yeah.
accordance with specification?
Yeah, it's supposed to be.
Yes. What we have?
I had like
Ah, yeah. 8 kilohertz. Yes.
If I
Right.
put a cursor on 8K
Mhm.
rate, it's here, so
Yeah,
it's
it's
okay.
Yes,
And
yes,
after,
yes,
if we
mhm.
put it also on 20, oh no, I haven't done it. It's animation is okay too, so it's okay.
It means the specification is realized. That's good.
So it's for my first. That was for Chelychev,
Mhm.
but there was also the same. Just I haven't done for Cower. We have to do the 3 or just one. And it
So,
works?
no, okay, I think it will be sufficient to have 2. Now, by the way, I would like to remind you that I have demonstrated you the paper with the cover realization. Anyway, please keep in mind, and if in your future work you have the task, something like that, you know the material, it is possible to see where is it and to realize the similar figure.
Yeah.
So just now we are
Okay.
only on the training program, and of course I think it will be sufficient. So in other words, we have Chebyshev and we have Butterworth.
Yeah.
Mhm.
Yes.
Okay.
And both work I can show you also, for example, just Butterworth. Let's see. Yeah. I have so for my Butterworth it was dBA. It's B phase B up. Okay, it's here and it's also there. I want to just Butterworth also work like yeah. It's the same and we have the same values and yeah. It's
But for cover, at least you can write here
The passive?
the passive.
Yeah,
yes,
I can.
At least, yes.
Yeah.
Of course, it is a very simple thing, and
Yeah, and it's
for your illustration, it will be good.
cover. It's here. See here. Yeah, I have here. Chook. Yeah, it's here. So it's the same.
Once again, 8 kilohertz here, and
Yeah.
0 and 0 in the second 0.
Yeah, I have to go further. Just 8 kilohertz. Okay, I haven't seen this. Okay, it's better. And just the limits, I have to go until, for example,
To the right side, yes.
Yeah. but not enough.
A little bit more.
Okay, so
Oh, yeah.
yeah,
Okay, that's correct.
31, yeah. So this is for me, and just I am so at the last part with switch capacitor, and I know you explained that last week for the entrance, like the sum of a lot of
Yes.
inputs, but
Spectrums.
yeah.
Yes.
What was the reason I forgot to it?
Because the possibility for microcap and all another platform, program platform,
Okay.
they cannot simulate the parametric circuit in the frequency domain. It is possible to use only time simulation.
How? I thought that to create the frequency graph, I thought maybe they would just have the voltage source go through all frequencies.
No, it is also possible, yes, right. It is possible to use the kind of stepping regime, for example. Yeah, maybe yes.
I
But
thought,
yeah, it is one of the possibility. I have demonstrated you the kind of very, very useful approach, you see, but this is another way. This is another way, and the result should be exactly the same. Say, in other words, you have the source, you have the generator, and you have the spatial regime where the frequency can be changed in accordance with any rule or something like that. That is, for example, with the same step. It is possible to take F minimum, F maximum, to divide to any steps, and after all to use the spatial order for the how to say, for the programming, yeah, for the programming of this source. So with this rule, F minimum plus delta, F minimum plus 2 delta, and so on, so on, so on to the F maximum. It is possible to be the same. My approach is very similar, but it takes a little bit more sources. So in other words, it will be the field matrix, we say, the matrix of the sources, and it will be summated using this spatial component.
Yeah, I just had the question on my mind. According to this table, it's not the same. So I don't remember, it was at the beginning of the semester. Here, the gain was the best for power, after a little bit worse here and here.
Yes, yes.
But for me, for example, I have between Butterworth and Chebyshev, I have a bigger attenuation for Butterworth.
No, but you see, the question is that you see the order.
Yeah. See,
Of
it's
course,
when-
the
when
order
over-
should be the same. Yes, of
yeah,
course,
yeah,
of
okay.
course.
Okay, yeah,
Yeah.
sure.
Otherwise, so look, you can take, for example, Basarot of 20s,
Yeah,
and of course it will be the best.
yeah, okay, yeah.
But
Okay.
of course they should be on the same position. Yeah, yeah.
Yeah, because when I did it, I was like, okay.
Yeah, yeah.
Okay, okay.
Of course.
And this you want to print? We have to print it or to send you in a file? Just for example, for the little like I have, for example.
No, the electronic will be sufficient.
Okay, because for example, for this it's quite small. I think it's if it's.
Oh, yeah, you mean that on the list of the
Yeah.
paper it
Here,
will not
here
be.
we can.
Yeah,
zoom,
yeah, right.
but-
It will be difficult to see the
Yeah.
details and so on. No,
So
I
it's
think we
okay?
can start. So look. First of all, we can start from the electronic version, of course, obviously. But after all, we will ask the administration of the university. But you see, each year we have something new. Just now, once again, the situation with the medical problems are not simple, and it depends on them. Because we can say that we are on the distant regime and it is not necessary to put it.
Okay.
So I
Because
think
in
it will be
general, with
sufficient.
the project work, we have to show to the administration that we
right.
did. Okay, because I just.
But if not, it will be sufficient, and that's all.
Okay. Okay.
So we will start from the electronic copy, and after all, we'll see. If necessary, we'll do it. If not, it is sufficient.
Okay.
It's okay, yeah?
Yeah.
Yes.
Yes, good.
Okay. So I have to finish with so my switch capacitor,
Mm-hmm.
and yeah, for to put the sources to yeah, I have begun with but I haven't finished for the moment.
I also will have a question to the switch capacitor thing, because I don't where is the analysis in the time domain in
Yeah. Open
okay.
please. Analysis open. The first. Translate.
Okay. Yeah, I still talking to
Yeah,
I don't know like
Yes. Once again, T minimum, T maximum. This is the time interval, first of all. So once again, of course, we need the information about the input, output, so on, the scale, and so on. More or less as usual. Of course, possibly you should play with these parameters, maybe here, because the question is that it is the parameters for the interpolation. Say there was how to create the graphs after the simulation.
Yes.
Say there was, for example, the number of points can be more. It depends on. Well, for example, okay. I can put. Oh yes, one maybe on the paper. So look. One detail. So for example, of course, this is the standard function, and the amplitude response should be monotonic. Chebyshev, for example, it is analog function. But you can have the result something like that. Of course, it is not physical. It is not physical curve. You see, it is very artificial. And the question is, the interpolation problem is not work well. It means that, for example, here the number of the points should be many times more. For example, 1000. Because the question is that it means that the interpolation net, also look, interpolation net, say other words, it is a number of points for the interpolation procedure. Is not correct. It is very small because, for example, here the argument is changed for the very wide situation, but we need a lot of interpolation points for the good solution of this task. If not, of course, we will have the problem something like that. That is not correct. It is necessary to change this parameter and to see how it works. Yeah. But it depends on you, of course, this is your work.
Yeah.
So play with this parameter to see how it is and so on. No, but normally it is a kind of illustration, of course. Is it necessary to say?
Yeah, just quickly.
Yes.
Yes, so I will show the I've done the cover one instead of the other one. But I have some problems with the results, even though I'm pretty sure that I've calculated, like with both of them actually, I noticed. The Chebyshev, somehow it seems to work quite well, but the starting point is too low.
So look, it should be, the reason of this situation, so Lina, also once again, can I the paper? So look, the reason of this situation is there. So look at here. We have the prototype. We have the prototype that can be demonstrated as this is a specific of the ladder network. We have here, and here only the reactance elements and input excitation. So this is the prototype, and the question is, if we are talking in this specific regime, when we have the matched parameter, And this is the conditions for the minimum sensitivity. I talk about it sometimes before, and it means that from the equivalent point of view, it can be presented as the structure like that. You see, because LC part will be how to say it? It will be just a moment. Compensated, we can say, each to other. Reactants with plus and minus will compensate each other. It means that we have here the situation like that.
Yeah.
And the transfer function of this will be so it means that we have which is equal to minus 6 dB.
Yeah.
And you have exactly this result.
Yeah. Yeah, I've compensated that for the phototropic
Right. If
display.
we are exactly, if we are talking about the active filter, it will be the kind of compensation of this negative effect. So for the active filter we have 0.
Yeah, but I don't have 0 and
Yes.
Yeah.
Well,
I'm wondering what the reason could be that I don't have 0 because
this is the active filter.
yeah, this is the active filter and the shape seems good. It's quite well matching, but somehow I must have calculated some value wrong.
So, are you sure that you have seen the output node? It's not any mistake because you have seen the results from the internal node instead of output. Is it correct?
I don't understand what you mean.
You see, possibly, yes, right. And it is correct that you have seen the output signal here, not here. For
Yeah,
example.
I've seen it here. Yeah.
Here it is correct, yeah?
Yeah.
So it means that we have to consider the structure. Let's try to understand how it is. And so this is the same element here, here, and here.
Yeah.
Oh,
These are all these elements are the same.
Yeah, and how much?
I think I've set it to 1 kilo.
1 kilo, yeah.
Yeah.
Okay, so just now can we simulate only this?
Only the first.
Only the, yes, only this circuit element, the total of course, from here to here.
Ah, okay. Of course. I will exclude it out.
And they see they have the same problem.
Yeah, so open please only the pass band here. We should see the situation with the report. And it should be Chebyshev.
Yeah. This.
Yeah. No, something wrong. Okay. No, it's just to see the elements, I think. So open.
This is the first one.
But this is correct, yes? And you have seen the results for the passive structure. It was correct, yeah?
Yeah. Okay.
Now, yeah, open please. I think this one, yeah?
Yeah.
Yeah, and just now we have seen. So open please with the more scale. Yeah. Yes, you see, we have the ripples.
Mm-hmm.
We have the ripples and this correct. 1, 2,
Yeah.
3, 4, so this is good. So on the second case we do not have so.
Yeah.
We do not have this. So it means there's something wrong on the calculation. So let's see, open please, yes, what we have.
Chebyshев filter.
Yeah.
I've not.
Yeah, of course. So we need your paper. So let's start from the first block. From the first block. I mean, so this integrate on this one.
Yeah. So, well, AS. This is the one.
That's
for the first
okay.
block.
Yes.
And then this is the T1.
Yes, that's correct. Yeah, and just now we have this one, it has a test transfer function like that.
Yes.
So it means what we have. This ratio should be equal to this one,
Yes, that's
and
correct.
this ratio should be equal to this combination.
Yeah, that's what it is in here.
That's correct. So it means that in general we should do the same situation with the basic prototype for this one.
So
And how many?
I've chosen Rn to be equal to Rs.
Also 1 kilo ohm.
Yes, Rn is equal to Rs, and then I've chosen in the Chebyshef active. I've also chosen R1T1 to be equal to the same. So both of them should just be equal.
Oh yeah. So this is 1 kilo ohm, this is 1 kilo ohm, here also 1 kilo ohm, and L? Where is L?
Yes, L1 is here.
L1
Yeah, and then from that calculate the CP1. L1 is comes from the passive structure divided by R and R.
Yeah, formula is correct, of course. Formula is correct. So, and taking into account that the prototype, basic prototype is okay, it means that this value is correct also. And if it is, and it is. So, which we have here? The inductor, where is it?
The
Yes.
PL1 is defined up here.
Yes, okay.
And that's the same value that goes into the passive simulation.
Yeah. 1, 0, 1,
This is the normalized value, and then here's the denormalization.
And here you have taken into account that here we have 2p. Yeah?
Yes, and omega C is 2p.
Yes, yes, okay. Yeah, that's correct. Yeah, in general it's okay. So, maybe let's go further. What we have? Maybe some mistakes. Is it correct that the numeration is correct? L1, C2, L3, C4, L5, C6, L7, and this is the output resistor.
Yes, and this is the same structure on the output as.
Так, so, and which, open please the prototype. So what we have here, the prototype, this one.
Yes.
Maybe it isn't correct. look, the question is that here we have the series connection of the resistor and inductor, but here we have another one. So it means that here there will be integrator, and after all there will be the block like that. So
Yes,
and how did you
uh,
calculate it?
Yes.
This one, yeah?
Yes.
Is that correct? So maybe I'll try to do
Both.
it. Yeah, and after all
Yeah.
compare. So what we have here? We have Y8, so which is the connection of two elements. P.
One moment.
Yes,
Not Y, no? Z.
no, you will start from
Ah, okay.
Y and after all the reverse. So this 8 also, I think like this.
Mm-hmm.
Yeah, that's correct. Plus and another one, I think. Yes. No.
Yes.
Yes. So, once again. Something like that, and that's one. Something like here. And also, yes. So Да, слушаю. Да, я посмотрел, я посмотрел письмо, в принципе, там все в порядке, в общем, написать эту бумагу мне надо выделить там час-два времени, в принципе. Но я думаю, что послезавтра готово будет, я пришлю. Ну, в общем, до конца недели будет вот эта бумага. Можете подождать?
No, it should be 0. And also, you look at that.
Ну, в четверг где-то, я думаю, где-то будет нормально. Я постараюсь это максимально быстро сделать. Завтра день выпадет, а вот где-то в четверг,
I
наверное,
have
выпадет.
seen
Я
like
думаю.
that the complaints and small
Хорошо,
details.
на связи. Всего доброго. До свидания. So look, T8, yeah, the next transfer function which corresponds to this one. It will be like plus 1. So, it means that it has the combination right here. So,
Last time, when I was talking about the frequency input, you took a picture or video or something like that.
is it the same?
Yes.
Okay.
On the side. So what about the side? It's plus or minus? So what we have here?
Minus the even.
Let's, yes, we will see.
It's cool, I didn't know that we could do that each time when it's like doing something like that, but just write, just I add just that. It's cool, like, great.
How many base?
Oh,
How many base?
oui, for the moment. Parce que sinon, je vais rien d'autre. Because I didn't part. No, you include the simulations and the records.
Stop. Just a moment, please. Open the camera.
I want to remove the tag. Concept.
Once again, here the value of the resistor will be equal to 1, and this here, and then 1 kilo, yeah? And RS will be also 1 kilo also. And here, C8. Generally speaking, I think it's to have the same value as with the prototype here. No, this one. And C8, how many on the prototype? Yes, here.
The value.
Yes. So, also look even here in new formula. It is TC8 multiplied to 1.5 and divided to 1. So just a minute, this is the correct one? So in general, we have only this one.
This should be equivalent with this, right? And here is the R1T. So, yeah, T, C8, open. This should be equal to C, T, 1,
And this is the for the prototype. No, what does 21? This prototype structure? Yeah, this the journey.
No, this is the active part, and this is the prototype.
Yeah, generally speaking, this is exactly the same because, that's correct. So say there is this complex, this combination should be equal to this one. So why we have here this?
Because
So in your calculation, we need this and this.
yeah, I have it here. This one R1T. It comes from that is the one this is the prototype part. Coming from the prototype.
So,
And
you
this
see,
is
I believe that it should be only the equal one, that's all. So in other words, from here we have this value will be equal to this value. Because R is equal to this 1 kilo, and this 1 kilo, it means that we have only this.
yeah.
So
they divide each other out in this case. I've left them in, even though they have the same value, to allow for value changes without changing the formulas. The Rn and the R are the same.
Mhm. Oh yeah. You would like to say that we have here C8 is equal to CD1 R1 D1 divided to Rn. Something like that.
Yes.
And if they are equal, we have exactly this. Take this one.
I don't know if this is maybe not true, but the waves are here, the ripples, but they somehow go up.
Yeah, of course something, well, you see, of course something is correct. Something is correct, but anywhere we have.
These increases.
Так, so, maybe, yes. What's the value of this? How many we have here?
A few months.
Minus 585 and here.
Minus
So, how many digits we got on yes, on your sort of just editor? Yeah, that's it. Because how many? Yes, it means that the accuracy of the elements exactly corresponds to the file.
Yes.
Well, let's try to do it step by step. You see, the standard, so by the way, dear students, so look, the standard way for the verification of the circuit, it is necessary to compare the results from the prototype and from the active filter. So in other words, we have the understanding which node corresponds on the prototype to the node of the active filter. So in other words, so for example, we can see the amplitude response from the input to the node number 2. And the same, we can see the amplitude response from this node to the node and this output. You see, not here, but here. And of course, we know that this structure is working well. It means that if we have the results which corresponds to this one, each of this block is correct. You see? And no, so it is necessary to see, is it or not? We will start from the first and here from the first. Let's try to understand, is it or not?
Can you get it?
Yes, yeah, of course.
I should, if I choose this node, or I have
Yes,
to choose
right.
this,
Of
this
course.
node.
No, this one.
But this condensator is already. I have to
We will
disconnect
see.
it. I can if I
No,
disconnect it. it's not-
we will see. We will see how it is. We will compare the results from this and the results from this and from this.
Okay.
First of all, simulate the structure with the output node on this position. Not here, but here.
Okay. I will just.
By the way, the simplest way is to put the number here. You can use the option. Where is it? I think this one. This is the numbering of the nodes. I think. Click it.
Node.
Yes, you see. So this is the numbering of the nodes, and it is possible to use it.
It just says node
No,
0.
not so. Click it once again.
Well, this
Maybe this
node
one.
node.
Yeah. What is it?
Number 12.
Yes, right. So it means that you can use this option of the limits.
Okay. Node number 12 with node
Yes.
number 66.
Yes.
And I just.
Yes, you can only change this. Yes, the number of the nodes, and we will see first of all the situation with the prototype. And so it means that step by step you can see how it is.
Yeah, so look, this more or less.
So already the
Yeah, but use the next block. After the capacitor on the active filter, the next node, yes, from this position.
It's really convenient.
Just now it's okay.
Yeah.
It's correct. So it means that this block is okay. So go to the right.
There's
Go to
already
the right.
the same.
No. So look, just now we have considered this effect minus 6 dB. It
Yeah.
should be. It should be because the prototype.
But on the prototype, and the prototype is the green one. The prototype is already at 0 because I've compensated in it by multiplying it by 2. While the active filter is not multiplied by 2 because it
No,
should have.
it doesn't matter. So of course this is the total circuit effect because just now we do not have the influence of the output block. Yeah. No, you can delete this doubling, I mean, to this one. But anyway, just now it is, we have seen that it is very similar. Say the words, I think that it is correct. And go right, to the right side.
Okay, so I'm
The
gonna
next.
compare
Yes, right, the next.
13
Yeah.
with 74.
Yeah, something like that. Yes, exactly. No, so it is necessary to see because you see it is similar, but something possibly here.
So in this.
Yeah. By the way, do you have the ideal model for the operational amplifier? Level number 1. No, of course. So change it here to the number 1. Yeah, and simulate once again.
Okay, I need to do that for.
Ah, yeah. Or of course, it should be done for all operational amplifiers. Yeah.
You should remove the color box
Yeah, this is really annoying.
or move it.
No. Yeah, maybe. I think just now it is the same. Yeah.
Come. Okay, maybe that's why there was one. Okay. It's the same.
It is exactly the
Okay.
same. I think it was the problem.
Okay, that's.
And just now, let's go to the right side and to see the output.
Yeah.
Yeah. For the verification, I think it should be okay.
Maybe my other problem was.
Yeah, but by the way, it was a very good illustration. This is the real influence of the operational amplifier parameters, you see, and it is a real picture. That is important. Of course, I would like to remind you that we should start from the idealized model, because it is necessary to be sure that the calculation is correct. Only after that it will be possible to introduce the parameters of the operational amplifier, you see? Of course, for the color, the situation is exactly the same. No, it is obvious. Yeah?
Yes. The color I have even worse
Yeah, it is possible because you see the sensitivity of the cover filter will be not so good as for Chebyshev. It is for Chebyshev it is better from this point of view, and so it means that the influence of these parasitic parameters, of course, will be here. In the cover case is more.
But they are all ideal. But
Just now, this I think.
cover and yeah, it does.
Yeah.
Oh, what happened?
So just now we have the good result.
This is, I have for weeks had not this result, and I did not change anything.
This is my
It
input.
was just a line like that.
Yeah, I see. No, but just now is correct. of
I
course.
don't.
Once again, it is -6. Yes, exactly. Look, it is -6.
Mm-hmm.
Yes. And this is the 0. That's correct.
I have been going out of my mind already because it was showing something completely
cover?
different.
No,
And
so
I
just
didn't
now
change
this is the
anything.
result. You see, this is the result. It's okay.
Okay, perfect.
Yeah.
And at the end we have to compare Chebyshev and Gomorrah.
Mhm.
Or
Okay,
the
so then the last that remains is the switch capacitor filter.
Mhm.
I will activate it. Oh, I have not really tried to run it. I'm using, this is my power source
Mhm.
with different frequencies. Analysis, transient.
you have to say okay.
Yeah. Out. SC. No, SC.
You have checked periodic steady state.
What do I have to check?
I think you will say that you checked it just
Just now.
So just a moment. So look, the figure on the time domain will not be informative for us. You see, because it will be the very difficult combination
Mhm.
of any discrete points of the time domain, the simulation, and so on. But the question is that after the time domain simulation, it is necessary to use FFT, fast Fourier transform, to transform the results from the time domain to the frequency domain. And it is necessary to start from the source. First of all, you should prepare the figure, the graph, with the input signal, in accordance with the illustration like I have demonstrated you 1 week ago, with the spectrums. So it is necessary to start from it. After all, you will use this source for the simulation of the prototype. For example, of the passive prototype, and you will have, for training and to check the results. Yes, just a moment. Yeah, so you can do the link between this output of this source to the prototype, and you see the input spectrum and the output spectrum for your training and for understanding how it is. And only after that it will be possible to transform it into the switch capacitor filter.
Yeah. I should be able to. Okay, perfect.
Yeah, of course it is the time domain result. Just now it is necessary to transform it into the frequency domain and to have the spectrums.
Where's it?
Now it is necessary to read something because on the help there is the special paragraph devoted how to use it, and of course you have to read it a little bit. Not too much, but only to understand so the symbols, algebraic symbols that can be included into the legend of the limits.
So here it's just the input with all the sources, yeah?
Yeah.
I will read about how to
Mm-hmm.
do some.
Yeah, but it is possible to do it here and at home, it depends on.
Yeah,
And,
yeah, I will do it now.
Yeah, yeah, yeah. And after all, of course.
So notes.
You see, in the simplest case, it is possible to do the kind of training exercises if you have only one harmonic, only one. You see, say, Anulius, you have the, for example, you have the source generator with the harmonic signal. It means that on the frequency domain you have only one spectrum line,
Yeah.
which corresponds exactly to the frequency of the generator. So it means that for the simplest case, we can consider the procedure how to apply the FFT. When you will be ready with one signal, of course, you will use the comb source and you will see the lines on this total spectrum. And after all, you can link it into the prototype, you will see the output lines. And after all, you will add it into the switch capacitor system. So this is the total cycle.
Yeah.
Something like that. Lina, the same situation.
Yeah.
This is the standard procedure to understand how it works and to
Mhm.
prepare.
Yeah.
So, but one more question. So, look, one more question. It is necessary to prepare the correct clock signal. Is it correct?
No, I haven't really. I've only done in the frequency. I've set a parameter. I've switched, but I haven't followed it. You have to make sure that it's exactly half.
Yeah.
Half.
Yeah, right. It is an important question.
Quarter of the.
Right, the quarter, yes, of the time period, yes, exactly. It is necessary to prepare also two diagrams with the first phase with the second phase to compare that it shouldn't be contact each other,
Okay.
overlapped. This is the worst case, of course, it should not be. So it is necessary to prepare the graphs, illustration, yes, with the clock frequency 1, with the clock frequency 2, and after all, to start the simulation with the switch cap.
Okay.
Something like that.
Does it work with two clock frequencies here though? Because it just looks like if the frequency is off, the capacitors are switched one way, and if the frequency is on, then the capacitor is switched the other way. Without an option of it not being switched at
Yeah,
all.
I see. You see, I never see. Normally it should be, of course, two.
Yeah.
Maybe you're right, maybe not. So,
Like this doesn't look like it can be off, like entirely disconnected.
You see, the point is that I don't like to use this model. You see, in the standard situation, it will be better to be sure about all things. My opinion, of course, to use the standard switch, not switch capacitor, but the standard switch block. You see, because on the library there is so the standard switch which has got two positions, open and closed, and it can be controlled by two phases.
Yeah, I tried to find that, and
Yes.
while I searched for that, I stumbled over this and.
Yeah. Maybe it works, but you see, it is necessary to simulate it very clear to understand how it is. And I think that the better to use the switches and so on.
Where is the switch?
Just a moment. please. Yeah, all this is correct. Yes, it's okay. Yeah.
Value. What's the value doing?
No, yeah, it is also the switch resistor in on regime, in off regime, and so on. So this is the show specification for this block. And so look, here is an example how to use it. So look, resistor in on regime, very small, for example 1 ohm, off 1 mega ohm, and the level which it is open and when it is closed. And for example, it is 1 volt, this is the 0, because your control voltage should be more than 1 volt, for example 1.2 or something like that. No, it is an example, of course. So put the specification, and after all you have the input node which can be connected with the control source.
Yeah. Okay.
Well, so Neil, how are you?
Uh,
Some questions?
for the moment, no, it's okay.
Mhm.
I do.
No, the same situation. Clock
Yeah.
signals, prepare it, prepare the combo source to see it in the time domain, frequency domain, connect it to the prototype to see for you to.
And just a question about
Yes,
the
yes, yes.
calendar. Just we are here. I've seen on the schedule online that the exam is here, the 20th of
This
January.
is January.
Yeah.
Mhm.
I
That's okay.
I looked on your schedule because we don't have a proper schedule because we are not in one group but in a lot of groups.
Mhm.
And so after we have also lecture with you.
Yeah, till the new year.
Okay, so here we just finished that.
Yes.
We send you.
Theoretically, so look, theoretically we have the last question concerning the cascade design.
Mhm, yeah.
So in other words, next time,
Mhm.
open
Yeah,
this
yeah.
book. Next lesson, we will see the paragraph here. Just a moment. Yeah. This is for your understanding of the situation. Number 5, section number 5, this one. Also look, we will start from this cascade design.
Mhm.
This paragraph, and after all we'll see something concerning it, so just a moment. From here, calculation of the section parameters.
Okay.
Cascade design, it is a combination of any sections. And the question is how to calculate it. And next time we will see some general ideas about this method, and after all some maybe some notions or some moments concerning the calculation. And it will be also possible to discuss how to realize the section, which kind of circuit can be used for that. So this is the last theoretical point.
Okay. Okay, so we will do it in January, yeah?
Mm-hmm.
Okay, and after for the exam, you will give us like questions before, or how it works?
Normally, the exam procedure can be considered as the following. You see, you have the theoretical question and you have the task.
Mm-hmm.
The task, it is the simulation of the integrator circuit in the Z domain using the charge voltage equations or using the Laker model, something like that.
Mm-hmm.
Yeah. And the theoretical question in accordance with our theory plan.
Okay,
Mhm.
so just the task question, the task, you just said that it's like a simulation on microcap No.
No, of course, on the paper.
on the paper.
Yeah.
You give us like an exercise.
But we have considered it.
Okay. like.
So open it. Yeah, of
yeah,
course.
yeah.
Here you have the catalog, for
Oh.
example. Yes,
Sorry.
you have the catalog of the circuit here. Right.
Okay.
Yeah, of course.
Okay.
Yeah, of
Okay.
course.
Okay, cool.
Yeah, something
There's
like
a
that, and
reference
it is
there.
necessary to obtain the
The transfer
function in
as
that,
in
in
Z
that domain. Yeah, of
Okay.
course.
Okay.
Yeah.
And it's 1 hour per student. How it works?
Sorry?
It's 1 hour per student, or because in the schedule it's written, I think like 3 hours or something like that.
No, you mean the paper? How to use it?
The exam.
Normally, no.
It's 1 hour.
No, you see. So look. Generally speaking, we have the special billet, the ticket or something like that with the text of the question. You take it, see, and after all, read it
Okay.
on the paper, and we will see the theoretical part. After that, you have the
So
circuit for the
circuit?
analysis. You will
Okay.
do
Okay. Okay.
approximately.
Okay. Thank you.
Mhm.
Thank you very much. Okay.
So, as the conclusion, my proposal for the next week, of course, you are working, and the same. It will be possible to demonstrate the results, and we will talk something concerning the last theoretical part.
Okay.
And after all, we have a time for the next lesson to see the final version of your circuit.
Okay.
So this is the plan for December.
So here, okay, next week and the. Okay, so it's the 20th.
Yeah, generally speaking, we should finalize it here.
Okay.
Yeah, 23rd.
Okay.
Mm-hmm.
Хорошо.
Yeah. Also, I think that's all for today.
Yes.
But in general, you are nearly finished, of course. I think you need about 1 week and then
Yeah.
No, yeah, okay, see you.
Bye, teacher.
That is such magic.
What?
I swear. As you saw my curve, nothing changed. Literally nothing. Like, it's exactly.
For car?
Yeah, for cover. Yeah, for this cover. Nothing changed. I changed it from you. And wired the results. Yeah, this is here the mistake was that one of the.
Just your inputs. So here it's.
Yeah, this is each different techniques. This is like 1 kilo I think I started 4 or 5 kilo.
And here so it's the addition.
Yeah, this is voltage controlled voltage source.
What?
You can find this source. You can find this source in the components. Dependent sources. This is waveform source, just like the normal voltage source, and then dependent sources, voltage of voltage. You can take this, and you have one input, one negative input and the positive input. You create it down, so it's plus.
Okay, so just. How you consider that this is
It's what?
how do you say that
You don't like this is basically just a multiplier of the difference. Like this one source.
just here?
Yeah.
This and this is okay.
Yeah, that's the input, yeah.
Okay. That's I was like,
Yeah, it's not connected.
Okay, and after we will switch to the store in
not. He said not to use these.
Why?
Because you don't really know how to control them. You see, because you can give like a frequency here.
Yeah, and so
But-
what does it hold?
It will I don't know how to. He said to use the normal, to use a switch, and that's what I was looking to do now. Wait, find component. You can get a switch, and then.
Yeah.
But I'm trying to figure out how the syntax of the switch
So-
works.
So and we keep that or yeah.
Sorry.
This we can keep it. Or
No, we have
also
to. I
switch?
think I have to replace all of them with switches of some sort. Like, yeah, just basically doing this myself by using 4 switches and a
Okay.
capacitor.
Okay. But it's really.
It would be nice if we could just use these. Yeah, I agree.
So.
Maybe I should look back into how to control them.
Okay. I have to check that. I have a new idea.
Simon. You use one
Okay.
shortcom.
Here, where?
Uh,
Where should I click?
below.
This here?
Yes. To use this to calculate emulated circuit. What circuit?
This I used to create this voltage, like to have a source with multiple frequencies at the same time. I have like multiple, this is like 4 kilohertz, and then this is 6, 8, 10, 12, 14, 18, 20 kilohertz.
After that, to elevated circuit, which circuit?
To
This or
No.
this or this?
this is the active filter.
Active?
Yeah, and I use it for the switch capacitor filter. Here is the input for that.
Okay.
But it doesn't work yet, so
Okay.
I don't know.
Come back home.
Actually, wait, where the fuck is the difference between these two? I just said the ground switch is similar.
Really, I didn't know.
I Can I do this about?
Here, for sure.
if you look at the schematic, they are just the same. They just look different, but they're the same.
What for me?
It's just like the arm is just flipped up. Like what we want is one that looks like that but has both arms up, right? Like this. Like this.
New era, I didn't have before. I don't know why. Just warning. No.
Thank you.
No pass to ground. Register attitude.
Oh yeah, I had this one a lot. No, I'm not sure actually what I did to fix it. What did you try to do? You tried to do an analysis, right?
I see, yeah.
You tried to do the AC analysis.
And look, it's here who has red.
Okay, but also a lot of other nodes. You think to that?
Look, just here. Yeah, the error it seems to be here, but I haven't done anything. And the nodes are
Resistors added.
okay. Or click on the circuit and maybe I should just do that.
I also have this error. After that, I delete on the do again.
Okay, it's okay right now.
You deleted everything?
Yes.
What?
After that,
Okay.
do again.
So, thanks.
Not correct, not error.
Oh.
I don't know.
Yeah, I mean, the simulations programs, they are all a bit weird. And Eagle is also a bit weird.
Yeah, but I just like Microsoft and Picker either.
Yeah?
Yeah.
I don't know, Eagle is like so frustratingly buggy.
Oh my god.
If it was open source, I would understand it, you know? It's not open source.
Yeah, I also feel like Simon Flatline. Hello?
I'm not doing this anymore. Close.
Okay, it's better. Multiply by 2 for the report, or it doesn't. Import.
I think it doesn't really matter,
Oh, I
but
think I
you,
want to.
you won't do it. I think I will do it just so it like lines up better with the elements. Like it's easier to see that it like fulfills elements.
Limits?
Like the
Are you drawn then?
no, I've only you've done it, no? You've drawn like
No,
a line here?
it's just 0.
Okay. Ah no, yeah, I've drawn like a line here and a line
How
here.
do you draw a line here?
You go, like the way I did it was
But I mean,
no scope, and then I went on not on add marker, maybe add marker. Yeah, add marker, and then you can have
Oh,
like a
ah.
horizontal line or a vertical line.
okay, thanks.
And just
Scope marker.
But I don't know, like I've seen in the project that they have like big like this,
Mm.
like an arrow on the, I don't know how to do that.
An error?
an arrow.
I saw just today I was like so because each time at home I was like is for example I put it here, okay?
Mhm.
But here look. Wow.
Ah.
So it's just you go on X or Y depending on what you want. And here you pay. And me I was but I think I prefer it depends but here
And how did you do all of that?
it's here and it's really great because I want and the question.
How do you do like delta, slope?
Delta is between that and that.
Ah, and then slope is the.
Yeah, but it doesn't mind. But the thing is that, for example, here it's really good. For example, me, it's, for example, I put 1. After I put 20, which is my cutoff, not my stop band,
Mhm.
right? Yeah, it's here. Okay, okay. So I don't know. No. For example, I want here it's right, left, but I want the two same both, for example, here and this is both. No, right, and also 1. And for example, here. No, I have done the same. So 1. I will take 5 just to clear. Okay, 5 to move. Okay, and here you see my value. It's so dark. Here it's a -6.
Mhm.
-6, you see.
Mhm.
Here you have minus 11.
52.
The delta is that, and my attenuation should be more than -66, so it's okay.
Okay. Yeah.
But for the brightness, just to be sure, for example, you zoom like on, for example, 5, 6, and you want to see the little took.
How did you zoom in white? Did you do?
Because me, it doesn't work for like you. I can't do that. I don't know why. Open source. And here, so I just change the limits.
Okay.
It should be great to have 8, 6. Okay, I don't have any right on here.
Mhm. Okay, just to. Maybe I also won't do that with the 2 because then there's
No,
like.
I won't.
Otherwise, there's just one line in the graph.
Mm.
And this is your fake. No, this is your ripple.
This is my
the different.
to see the ripples. Yeah.
Yeah.
It's for my second.
How do you take the pictures? There's an option, no?
No, just on Word. Like.
No, I mean, how do you take the picture in MicroCap? How do you make a screenshot?
Hmm?
You make but there's another option.
Yeah,
Let
I've
me
seen
show
it.
you.
I've seen
Because
it
it's,
actually. It's like.
It's also really great to like take a picture of the.
Okay. It is.
I think like I don't know where it was edit, export graphic file.
Yeah, I've seen it, but I don't like that.
But this is from the circuit. And I don't want the circuit, I want this.
Yeah, but me, I don't want to do it, and you know why? Because each time I change something, like when I have, for example, here I've corrected something, and I don't want on my folder a lot of circuit, because after I don't know what was. Yeah, I prefer taking.
But if you
like
do screenshots, you also have a lot. No?
No, because it's just on Word.
What?
Like I just do something like up from here.
Oh wow, okay, I didn't know that works. I
So
also I'm not
I
using Word.
prefer.
I'm not using Word, that's why.
Oh,
So I don't know.
LibreOffice.
No, I do LaTeX.
Yeah. Yeah, I've seen on what is the name? I don't remember.
But I need to take pictures for that.
What is that? I don't remember.
The website
I know. I worked on it.
What's the name? Right here. Overleaf.
Yeah, sure.
Yeah, it's really. I like the look because I have Linux and I don't have Word. I cannot do it in Word, and in OpenOffice it's so cringe and it looks so ugly and like every time you do something like the formatting fucks up completely. It's terrible, and I like the look of.
Your report?
Yeah, I haven't really done that much for the
What?
report yet, but
How many pages?
no, I don't. I only have 10 pages now because I haven't put any. Oh, this is not my part of my report anymore. This is just the thing I copied to not do the formatting. Not do the formatting of the report. I copied the document. In the university they have templates. They have LaTeX templates.
I really like LaTeX.
Yeah.
When I was in high school,
And look, makes your work look so professional,
Yeah.
like nothing just happened that impressive.
Gericht.